Hey everyone. Today is lesson 3 in our derivative journey. Where are we so far? Well, first of all, we established what a derivative was, and finding the derivative is the same as saying we're finding the limit, which is the same as saying we're looking for the slope of a tangent line at a particular point. Now, the derivative often is looking at the general equation, um, which would represent the slope for any given tangent line along the entire domain. Okay, then we started looking at, okay, well, how can we calculate the derivative without actually having to go through first principles and do all of that work through limits? So yesterday we talked about the power rule. And the power rule stated that if we had something like, oh, I don't know, let's say we had 3x squared. Okay, well, what that tells us is that the exponent is going to come out and get multiplied by, so I should just be a little more careful here. Let's say that that's f of x, and now I want the derivative. So I'm going to say f prime at x. Okay, so the exponent comes to the front and gets multiplied, so that'll be 6, and then the exponent drops a degree, so that'll be 6x to the 1. So the derivative of 3x squared is 6x. Okay, that's what we dealt with yesterday in lesson 2. Today is like super easy. We're going to look at sum and difference of derivatives. Okay, and essentially it says this: the derivative of f of x equals x cubed plus 2x can be found by taking the derivative of each of the individual terms. That's it. So we say d over dx of x cubed plus 2x will equal the derivative of x cubed plus the derivative of 2x. So you have to figure out the derivative of x cubed, which we could have done yesterday, right? The 3 comes to the front and then drops the degree. The derivative of 2x, the 1 comes to the front and drops the degree, so that's actually going to be 3x squared plus 2. Okay, that's it. That's all we're doing today. Okay, so easy peasy, just giving you another chance to practice. Really, we're looking at the power rule that we did yesterday, but we're just doing it several times because we have multiple terms going on in our function. Okay, so differentiate the following. I've got x squared plus 4x. The derivative of that then will be 2x plus 4. Okay, again, the 2 comes to the front, and then the that particular term drops a degree. For 4x, the 1 comes to the front and it drops to x to the 0. Okay. Okay, differentiate. So 5 comes to the front, so I'm looking at my first term would be 15x to the 4 minus 24x to the 3. The 4 came to the front and I dropped a degree. The constant term drops, so I'd have 15x to the 4 minus 24x to the 3. Okay, so if you understood yesterday's lesson on the power law, this is super easy. It's just doing it a couple of times in the same question. Okay. Okay, and then f of x equals x squared minus 2 over x squared. So this one maybe requires a little bit more thought. This guy, 2 comes to the front, so that'll be 2x. Okay, this guy right now would be, actually, I'm going to write it down here because you might not be able to see. My big old head might be in the way. Negative 2x to the negative 2, right? I would always kind of write it like that first, just so that you have that kind of visual. Negative 2 comes to the front, so that'll be positive 4, and then the negative 2 will drop down 1 to be negative 3. Okay, so that's going to end up being 4 over x to the 3. That's where we get that from. Okay, so I would kind of write it as a negative exponent so that you can see how the exponent comes to the front and then drop down 1, but then your answer should be as a positive exponent. Now, not only should your answer be as a positive exponent, life is much more beautifuler, life's better when we have this as one fraction. So I would want you to answer this as one fraction. So I want you to essentially think about 2x multiply that by x cubed over x cubed so that I have a common denominator there. So that'd be 2x to the 4 over x cubed. That way we could write it, oops, sorry. That way we could write it like this. So 2x to the 4 plus 4 all over x cubed. Whenever possible, your answer should be one beautiful fraction, because fractions are beautiful. Okay, now I'll clear that. And that is it. Okay, so you have another 2 pages to practice here. Again, just getting solid on what's going on. And then we'll pick it up here for tomorrow. Okay, if you have any questions, you know where to find me. Have a super awesome day. Take care.